evening, folks. This is Chris Evans from Google, and let me present with this Pwnium Elements 1337, yeah? All right, Chris, you have the floor. Thanks.
Okay, thank you. So yeah, my name's Chris Evans, currently working on Google Chrome. I've been promoted since I was last year at Hack in the Box. I'm now a senior troublemaker, and the way you get promoted from a troublemaker to a senior troublemaker is you launch lots of things like Pwnium, which get quite a bit of interest. So before we start with the actual presentation itself, we have some special rewards to announce. In a way, these were a hedge against not getting anything in for Pwnium, so that if we got nothing in, we could still give some money out. So we have two awards to give out, the Last Man Standing Award and a specific achievement award. And I don't know if this is going to work, but I'd like to see if I can get a volunteer from the audience who has a camera and a Twitter account. And a working internet connection. If anyone wanted to, they could take a picture of me sort of live awarding an award, and one of the guys I know who's going to be a recipient is permanently on Twitter, and we'll sort of see it firsthand, maybe via a photo someone were able to take. So this is the guy. We're awarding him $10,000 for the Last Man Standing Award. And what the Last Man Standing Award means is that over time, this guy's consistently been sending us reports of high quality. And whenever he exhausts one area of bugs, he just moves on and finds another area of bugs. And a lot of people have sort of found a few bugs in our reported a few bugs via our program and then given up. This guy seems like there's nothing we can do that can cause him to give up. So we're giving him $10,000 award, and I don't see anyone with a camera and a Twitter account out, so I'll just have to send him an email or do a tweet myself when we're done. So actually, we're going to give out another $10,000 award for Last Man Standing to another guy called, with his Twitter account is Ataket. I think the name's Ataketinen. I believe both of these guys are from Finland, and we're still not quite sure what it is about Finland that it's quite a small country and a population relative to the world, but a very high proportion of incoming bugs from Finland. And we're still trying to work out what's in the water there so that we can drink some of it ourselves. So he's getting $10,000 for also, recently he's been sending us a fantastic variety of bugs across all areas of the code base, and we're very impressed at his persistence in being able to find these bugs. This is actually, I believe, a Mozilla employee here that's getting $10,000. One thing that's not widely known is that the Chrome guys, my team, they find a lot of bugs in Firefox and send it over and get some rewards occasionally. And there's a guy that works for Mozilla that sends us a bunch of bugs in Chrome, and we send him a bunch of rewards. So amongst the open source browser community, there's actually a lot more collaboration than you might realize. So this guy's getting $10,000 because he's done a lot of work in the specific area of our V8 JavaScript engine. He's got some very interesting JavaScript fuzzers, and he's found a very large number of very interesting bugs and sent them over to us, and we've been very happy to fix those. And again, over time, he keeps finding more bugs, and he's also very good at catching regressions, and we particularly love that because if someone catches a regression, we can fix it before it ever ships to a stable version of our browser, and it impacts users. So that's $30,000 given out already, and we're only about 3.5 minutes in. So let's see if we can keep this up. So here's a gratuitous picture of the periodic table. It's actually the widest one I could find. And unfortunately, the sort of theoretical physicists who sort of try and make some of these elements aren't doing very well. They're only up to number, best I can tell, the one they've made number 100 and, see if we can get a laser. Well, number 118 somewhere over there, and I've reserved the name for element number 1337. So if they ever get high enough to make that, we've pre-named it Pwnium and booked that name. So here's the agenda. Here's what we're going to cover today. We've already covered the surprise rewards. No one's surprised yet, I don't think, because we didn't have the camera and Twitter thing lined up, but they'll be surprised soon. We're going to cover a history of the reward programs, not just ours, but sort of industry-wide. We're going to get into the history of Pwnium. Pwnium's only the age of Pwnium really is measured in months, but it already has an interesting history, some might say, so we'll cover that. There'll be a tale from the war room. That's just a sort of peripherally related story that we've never told before, something that happened in Chrome security that we thought was kind of fun, and we haven't told the story, so we're going to tell that story just briefly. And then there'll be some stats on how the program's doing overall since we launched it. And then Pwnium 2 results. We do have some results to give out there, so that's quite exciting, and then we'll take some Q&A with any time we have left. So here is a timeline of some well-known vulnerability reward programs, or reward programs in general. We decided to start in 1981, where a very famous computer science guy, Donald Knuth, actually gave out bounties for bugs in a book he wrote. And if you found a bug in one of the algorithms he described, he would just cut you a check and send it to you. So we thought that was a fairly early version of bug bounties, starting in 1981. In terms of bugs in software, one of the most famous programs is, of course, the Mozilla bug bounty. It started off as the Netscape bug bounty. We think that dates back to about 95. I don't know if Lucas is in the audience. He can correct me if that's wrong. That's still going strong. In 2002, we had the start of some companies that are sort of third-party brokers. They buy vulnerabilities and then typically use that to bolster some product they have and then send the details off to the affected vendor. Mozilla 2004, that's an extension of the Netscape bug bounty. ZDI, similar to iDefense 2005, and then we're starting to get quite a few popping up from 2007 onwards. Pwn to Own, of course, is a similar thing to Pwnium. We'll cover that a bit later. The Chromium rewards program actually started January 2010, so it's 2.5 years old now already. It feels like only yesterday that we launched it. Partially spurred on by the success of the Chromium reward program, the sort of Google website side of things launched their program. That was one of the first forays that we know of to sort of invite researchers to make money off of website bugs. Had some interesting legal discussions to launch that, but it seems to have gone just fine. And lots of people have piled on since. We have Mozilla added their websites to their bounty program. Quite famously, Facebook have waded in and they will pay you money for XSS and so on in their website. And since I wrote this slide, I haven't updated this actual picture since I wrote this slide, but I think it's interesting to just list the vulnerability programs I've found that have launched since I wrote that slide, and it's not that old. So did you know if you find a bug in a Samsung TV, you can make some money? If you go to the URL that they list for their Hall of Fame, you can see that it's empty, so you could make history by being the first person to make money off a bug in a Samsung TV. PayPal is obviously a very, very well-known and high-profile website. They launched their program just a few months ago in June 2012. And one thing just as I was researching, I noticed that as it was launched, the sort of head guy at PayPal security in the blog post that launched this program said he had reservations about the idea of paying researchers for bug reports, but having studied the data, the publicly available data of the people such as Chromium and Facebook and Google Web, seeing how those programs had actually gone, he was swayed by the evidence that he should go and launch a program for PayPal. Okay. So the history specific to the Chromium reward program, when we launched, the rewards we offered were between $500 and $1,337, with most rewards at the time going out at just $500. When you dip your toe into the water, you do so cautiously. It went well. We felt that we could safely increase the reward amount, so we fairly quickly increased the top reward from elite to elite, $3,000. Less well known, we've actually been expanding the scope of what we cover in the program since launch. Did you know that we will actually pay for bugs in Adobe Flash or the Linux kernel? These are things that we use in some of our products like Chrome OS that comes with a copy of the Linux kernel, so we'll actually pay for bugs in all sorts of open source software and obviously contribute those fixes immediately back to the repository, to the bugs and fixes sometimes back to the owning project. And just recently, in August, we sort of upped the rewards again. So we put our top reward at 10,000 plus, where the plus illustrates that we've always reserved the right to reward arbitrarily beyond our top level if something that really impresses us comes in. And we added a bunch of bonuses. So we sort of now have a bit more of a focus on exploitability. Previously, for a $1,000 bug, we might pay out for a bug that's probably not exploitable and pay the same for a bug that probably is exploitable. So with these new bonuses, we start to take more of a detailed look at the bug and sort of top the $1,000 up to maybe $4,000, or if something's particularly exploitable in our opinion, or if someone can just prove to us that it is, then it's sort of automatically topped up. One example, we used to pay just $500 for a class of bug called an out-of-bounds read. And that, again, would range from non-exploitable to particularly exploitable bugs. And just recently, we used this new, I don't think I pressed anything. Let's see. We used this new bonus structure to pay $3,500 for a bug that would have previously been rewarded at just $500. So does someone have a spare clicker and they're like pressing in the back of the room to? It's a bug. How much is it worth? I'll pay someone $10 if they can stop it happening. Okay, so the history of Pwnium, like I said, it's very new, but there's already a history. So it sort of starts back in February 2011, where we sort of piggybacked the well-known Pwn2Own contest. We said, well, we kind of like this contest. We want to put some more money into that contest to motivate people to go after Chrome instead of the other browsers, because at the time, not many people were going after Chrome in Pwn2Own, and we wanted to motivate people to go after Chrome so that we could get some interesting things in and learn from that. I mean, you can't learn if you're not receiving any reports or any exploits or any bugs. So we threw in a $20,000 top-up reward, sort of motivate things in the Chrome direction. And we were planning to do the same again in February of this year. So we sort of agreed that we'd do the same thing. And then there was a misunderstanding, which is probably not worth going into, which caused us to withdraw sponsorship. And this is in February 2012 with CanSec West, where Pwn2Own is held, going on just a month later. And since we'd already announced that we were going to do this top-up and then had to withdraw, we kind of felt bad. What if we had motivated a researcher to go after Chrome based purely on the fact they might get a top-up reward specific to Chrome? So we felt kind of obliged to launch something that would let that researcher's work, if they'd started it, still have the same sort of value. So with minimal planning, we sort of hastily launched Pwnium. And then it did very well. Don't want to go into any details because we don't have enough time, I don't think, but we did quite a few blog posts detailing the fantastic submissions that we got. We paid out $120,000, and the amount of data we got from that and the amount of things we learned and the hardening measures we were able to apply to Chrome were invaluable to us. So we were very happy. And then now, Pwnium 2. That's the history. So here's just a little diversion, a little tale from our war room, where a war room is something interesting comes in, and we sort of all huddle around one of the offices and deal with it. So in May 2011, a company known as Vupen issued what we call a non-disclosure. It's where you sort of purport to demo a vulnerability, but don't give anyone any details so that they can go about fixing the vulnerability. And that was disclosed via a YouTube video. You know, I'm sure you've seen the sorts of videos where there's sort of a browser in the video, and the browser visits a website, and then up pops a calc. And it's like pwned, and there's not much you can tell from that video. Or is there? So from my experience working in a variety of security teams, a normal security team would just say, this is ridiculous, this is a video, it's an unverifiable claim, just hand it off to the PR department and get on with our day jobs. If you're a Google security team, what you do is you undertake a detailed analysis, pixel by pixel, of the YouTube video. So this is a freeze frame of the video. It's a few minutes long, so I'm not going to show you the video, but this is a freeze frame in the middle of the video. It's after the pwn has purported to have fired off. You know, a calc has appeared and then been minimized. So this freeze frame shows sort of the pwned Chrome in the foreground with a Windows process manager, or whatever it's called. I'm a Linux guy, in the background, showing, and the reason you've got up a process manager is to prove that you have unsandboxed code execution, as in you bust out of the sandbox. And one of the labels in here is medium, and on Windows that means you've bust out of the sandbox. So I don't know if anyone can see anything suspicious or interesting about this freeze frame. Probably not at the range you're at, but anyway. The first thing we noticed of interest is here, and there's a little zoom in of that section. If you notice, just slightly above the Chrome logo in the process tree is another logo, of which just 2 pixels, vertical pixels, is exposed. It so happens that the only possible logo that can be in the Chrome process tree is a process named run32.dll, which is just a name. What it means is that Adobe Flash has been instantiated. So this is a massive clue, and just 2 pixels leaked a whole amount of information here. That's not it. That's not everything. What we've highlighted now, see if the laser pointer is going to work a little bit, is 4 processes that are the 4 Chrome processes running. And this particular configuration of number of processes and integrity level of processes indicated also is uniquely consistent with Adobe Flash having been launched. Just to confuse us, initially one of these things is actually mislabeled by Process Manager, and that's a known race condition in the Process Manager. So that confused us for a bit until we went and did some experimentation and understood what was going on. The sort of virtual memory size, I think that's the virtual memory size, and that's probably the heap size. I'm not as familiar with Windows, but it's clearly shown. So the Flash process, well, there are 2 Flash processes, but this one is showing as 400 megabytes in size, and that's particularly large. It sort of tells you that, combined with the length of time the exploit took to run, it tells you that some form of spray has gone on. So that was a clue that we also used in our response. And finally, and this is the weakest piece of evidence, very circumstantial, but you can see there are some scroll bars in this window, which implies that there's a large HTML element that's sort of blank, that goes beyond the bounds of the window, and that could our interpretation was that that's a sort of hidden plugin element. So just one freeze frame and quite a lot of data leaked there. So enough for us to conclude with absolute certainty that we should go and do something about the security of Adobe Flash. And this was marketed as a Google Chrome exploit, so it was like a bit of misdirection there. So but we dug into it and said, no, we're going to go and look at Adobe Flash. So response. Who's heard of Tavis? Who's heard of Tavis? Tavis Ormandy, if I give the full name. Okay, a few people. He's well known in the security community for being a bit of a machine when it comes to research and finding bugs. So we decided to wheel out the Tavis, our secret weapon, and we paired him up with another of our secret weapons, which is a large amount of computing resource. 2,000 CPU cores. I think he's been using more since then on other problems. He used those CPU cores to download every Flash file on the internet and do some analysis on them so that he'd get a set of these files that represented a large amount of coverage of Flash, so that with a minimal set of files you can get a good sort of testing basis, if you like. That was 20,000 files. And then using those same 2,000 CPU cores, he proceeded to do some fuzzing, resulting in about 100 bugs. We don't know if we got the specific bug in the video, but a bunch of researchers were sort of, my bug, you've killed my bug. So we killed some bugs. So that was rampage number 1. Rampage number 2, we thought, well, there's obviously something wrong with our Flash sandbox. Let's lock it down. So we added some lockdowns that we found based on an internal review. We found some memory corruptions in an area where we don't want memory corruptions. We fixed those. We accelerated work on something known as Pepper Flash, which is now launched, which brings Flash into the same strength of sandbox, give or take, as the core Chrome browser. We went on a third rampage. As mentioned from the freeze frame analysis, we thought we detected a bit of a spray due to the size of the process after the exploit had run. So we actually applied some lockdowns to Flash to limit the amount of a certain type of thing it could allocate, called a JIT mapping. This really was a rampage, so we went a bit too far, and this string here, which doesn't mean anything in particular to a user, although to us it means that the that this cap that we put on had been breached. Unfortunately, that was shown to quite a few users due to certain flash files using a lot of these things. So we had to sort of back that off. It's unfortunate, but definitely part of the story. And finally, we invited the community, Rampage number 4, to join us. We said, well, let's just pay for flash bugs to sort of scale up the number of eyes looking at flash. Again, this doesn't seem to be widely known. We haven't received many submissions in flash, which we've paid for. But we will do so if anyone wants to send anything in. So just some stats from our program so far. So we've actually paid out, this number's now out of date, because since I wrote these slides last night, I have to admit, we've actually issued 4 more rewards. That's 489. The total reward payout across those 485 rewards is 2 million local currency, Malaysian ringgit. I've done this joke before in Brazil, and where the difference between Brazilian currency and some other nearby currency I chose was a factor of 50 or so. So there were some gasps from the audience, whereas ringgit to US dollar is actually about 3 to 1. So that's $650,000. And that number is also stale. That's gone up to closer to $250,000 based on the rewards issued within the last 24 hours or so. That's just the Chromium program. Google also has this web program, which is rewarded a bunch of money to researchers. So the total across Google-wide is in excess of $1 million US. And given that we keep expanding the programs and pushing the numbers up for what we pay, we're hoping that this $1 million will become $2 million and just keep going up over time. Feels pretty good to be able to reward the community for work that helps make everyone safer. I'm not going to go into a huge amount of detail in this talk, but sometimes when we do a talk similar to this, we're sort of trying to convey to people who are thinking of launching a program what challenges they might face. So to just go into a little bit of detail there, one slide we wheel out is a slide that illustrates the sort of relative ratio of bugs you get before you launch the program, which is sort of up to Jan 2010 here-ish, versus the quantity of incoming reports after you've launched a program, and it sort of goes, way, up by a factor of maybe 4 or 5 in this case. The point being, you should launch one of these programs because you're getting some bugs that will enable you to make your users safer, but don't do so until you've got your house in order. You need to have enough staff on hand to handle a 5 times increase in the incoming load of bugs that researchers are sending in. I mean, it's fine to get a huge number of bugs in, but there's only really benefit to your users if you have the manpower to triage and fix them. And just to underline the point, when we launched the program for Google websites, the spike was significantly larger, actually. That actually represents a times 10 spike in number of incoming reports. And we don't know for sure why. We're sort of waving our hands around. We say, well, it's kind of a lower cost of entry for a researcher to start going and trying to find XSS in a website than it is to go and find a memory corruption in a browser. But yeah, there's a definite times 10 spike in incoming load here. And it backed off, but to a level that is something like 4 to 5 times the level of incoming reports that we had before launching the Google Web program. So do launch a program, but do beware before you do so what you're getting yourself in for. I did see a little mouse cursor whizzing around my display down here, and corresponding with that, the button doesn't work. I don't know if anyone is able to manually hit next slide for me. Second bug. This one's worth $40, twice as much as the first bug, I think, because this is actually a much more serious DOS. Do we have anyone working this? The green button? Yeah. Does it go back or just forward? No effect.
Just the green button.
Hmm?
Just the green button on top here.
Yeah, it's not doing anything.
Oh, you need to play video?
No, I need to go to the next slide.
Oh, you still have to use this.
Doesn't work. Given that we don't know how long it'll take to fix this, I can take an inline question if anyone has anything so far. Yes? I'd love to go back a couple of slides.
But you had multiple categories of bugs, whether they were low priority, high priority, medium priority. Can you describe just briefly what your categories are?
Sure. So the question is, what are the categories of bugs we have? And we rank them by severity, ranging from low to critical, with medium and high in the middle. And we sort of have some textual descriptions that are published that sort of say what each bug represents. At the top level critical, it's essentially where a single bug might compromise the local user account. We don't have many of those because of the sandbox. A lot of our bugs are the next level down, which is high severity. In fact, the majority are. And a high severity bug is essentially possible or probable code execution, but confined within the bounds of the sandbox. Still a very serious condition, but someone with one of those bugs has to then bust out of the sandbox in addition. Medium is sort of a catch-all for something that's not quite bad enough to be high, but is a bit worse than low. And low severity means a bug that we're not particularly worried about, but it's technically a security issue. Brilliant. So, already we're on to the Pwnium 2 results. So, we had an entry and a non-entry. Hat off, actually, to this guy on Twitter. I've not met him, but the name's Nikita Tarakanov, and he was sort of live tweeting his ongoing battle with a Pwnium entry and his sort of rising and tumbling fortunes trying to get something to work. You don't normally see this. What normally happens with these competitions is you give researchers a bunch of notice and say, we'll give you a bunch of money if you can come up with this, and they all the interested researchers go away, spend a bunch of time trying to get something going, and they'll either turn up with something that works or they won't turn up. There's a misconception that if no one turns up, no one tried, and that's absolutely not the case. A lot of people try and just don't quite get something working. I mean, if you don't get something working, it's not like you're going to come up on stage and sweat a little bit and then say, I can't do it. So I was actually really pleased that Nikita sort of live tweeted his non-entry, which kind of dispels the no one entered myth. Very clever guy, so let's go into some more detail on that. He had, if you're going to break into a sandbox browser, you need one way to do it is 2 bugs. You get a code execution inside the sandbox, and then you get another bug that busts you out of the sandbox. Busting out of the sandbox is probably the more interesting half of that, and there's one very popular way you might go about trying to do that is find a bug in the underlying operating system kernel. If you can get code execution inside the kernel, all sandboxing bets are off. So Nikita did have a kernel driver vulnerability. He actually, just to back up a bit, as we launched Pwnium, we carefully documented the exact laptop model that was going to be used for Pwnium. And that was in response to feedback from Pwnium 1. People, Pinkie Pie, in fact, after Pwnium 1 said, well, if you just told me what laptop you were going to use, I could have gone after the GPU driver if I'd known what exact GPU you had in the machine. Instead, you inconvenienced me and made me go after something else. I don't think he was inconvenienced at all based on his win in Pwnium 1. But anyway, the point was taken, so we said the exact laptop model that was going to feature in Pwnium 2, and Nikita promptly looked up what wireless driver it had in it and went after that. I guess one postulation you could make is that the quality of third-party drivers shipped with Windows might be lower than the core Windows kernel itself. In this case, he was right. He found a bug in the driver's ioctl implementation, and it led to these messages from Nikita on Twitter, or this message, one of his messages. He found out that unfortunately, his kernel Ode didn't work inside the Chrome sandbox. The reason for that is one thing sandboxes do is they limit the handles you can open, or they limit the capabilities of handles once you've opened them, and that was sufficient in this case the Chrome sandbox was sufficient in this case to prevent him from running this buggy ioctl code inside the sandbox. However, there was hope because this year in Pwnium 2, what's new is we're paying out partial rewards for people who have a partial exploit. So say if you get code execution inside the sandbox but never quite break out of it, that's worth a partial. So not to worry, Nikita had the other half of his 2-bug chain. Regrettably, it was in Flash. And we'd just gone on a second Flash rampage, different to the first Flash rampage that was covered earlier. And that second Flash rampage caught the same bug that he had, was planning to use, and Nikita was displeased. However, thanks to Pwnium 2, something interesting came of this. The Broadcom driver bug that Nikita had, he no longer had a use for it. He wasn't entering Pwnium, so he thought he would just drop it as an O-day. So we've got a nice, really interesting bug that's been published. There's the link to the paste bin describing the bug. Kind of interesting. If you're a defender, it's particularly useful to see what people are going after and how, and what sort of bugs are out there in third-party drivers. So I see this as a win for Pwnium 2. We've shaken out, without paying anything, we've shaken out a bug in the Broadcom wireless driver. But Nikita very graciously finished by asking that someone should save me by dropping an elite exploit at Pwnium 2, with the point being that my talk would have already ended by now to an extent if there had been no Pwnium 2 entries. So enter Pinkie Pie. We have a confirmed $60,000 win for Pinkie Pie. This is the second time he's done that. The guy's a bit of a legend. This image here is the image that appeared on the laptop on the Pwnium 1 competition as his exploit worked. Kind of scary when you're sort of staring closely at a laptop to see if the pwn's going to work, and this jumps out at you. So this is a second $60,000 win this year. It's $120,000 just in Pwnium wins for the year. And awesome, we're very happy to have him, having had him enter again. So obviously we actually confirmed, this isn't the first confirmation of the win, we actually confirmed the win earlier, sort of last night, actually in Malaysian time. We confirmed the win by actually releasing a patch that closes the holes he used. And when we release a patch, we announce any rewards with that patch. So our release notes for the Chrome patch that just went out included a $60,000 reward for Pinkie Pie. We're kind of pleased with the time it took to get the patch out. We always like to sort of push ourselves where we can. So we set ourselves an informal goal of being faster than, releasing a patch faster than we did for the Pwnium 1 competition. Pwnium 1 was less than 24 hours, as in just less than 24 hours. Pwnium 2 is about a 12-hour turnaround. If we're being honest, we were helped by the time zone difference here. So what happened is we sort of received the exploit at 2 p.m. local time, handed it off to what we call our home team. That's a team back in California. It's approaching, it was about 10 p.m., 11 p.m. there. And then, embarrassed to admit, we sort of went drinking whilst the home team is sort of sweating it up at midnight after a long day back in California. But we were thinking of them. We were there in spirit. So, and they dealt with the bugs, checked them in, kicked off all of the automated stuff that tells you if you fixed it correctly without regressing anything, and they went and slept, and then they got up the next morning and the overnight run and said, yeah, it's all good. And then they released 8 a.m. or so Mountain View time, midnight or so Malaysian time. So if we use Malaysian time as our benchmark, we've got a same-day patch out, which we're fairly pleased with. And it wasn't even a real emergency. The term O-Day is misused quite a lot. If back is working, that's a real O-Day by Nikita. A real O-Day is when the first time a vendor hears about a bug is if a user's being exploited unexpectedly, or if someone drops something on full disclosure unexpectedly. If someone gives you a private notification of a bug without telling the world or exploiting anyone, then that's not an O-Day. But not a real emergency, but we do like to give the engines a test fire. What if one day we do get a real emergency? It's good to know what sort of response time our automated infrastructure that sort of does the build and the test and the packaging up and and all the stuff it does is quite complicated. What's the minimum time that we can get that to run in so that if and when we do get a real emergency, we can protect people very quickly via our automatic update. So we like giving the engines a test fire. It's time for some pictures. So this picture was taken from behind the Google desk as the entry was coming in, the Pwnium 2 entry was coming in. So let's check out the laser pointer. So this is our product manager's laptop screen here. I thought I could make out some interesting text in his email, so I've blanked that out. Pinkie Pie wasn't here on site, but he had a friend here, which is good because he was able to enter by proxy via this friend who was then able to sort of accept the rules on his behalf and send us the link, which we then checked, and it looked pretty legit, so we sent it off to our home team for formal validation. Some interesting things going on in this picture here. There's me here. I've sort of got a bit of a lean going away from the laptop, as if there's raw pwnage coming out of the screen. And this guy here, I don't know if Pelis is in the audience, a friend of mine, works for Adobe, and he has a look of terror on his face. I'm not sure if you can tell from where you're looking, and this is what he's thinking. And it was not in Flash. And I actually asked Dylan for any photo of the situation as it's going down, and he randomly picked this one, and it occurred to me that I've got a T-shirt on that says property off. Well, I'm now pretty thoroughly the property of Pinkie Pie because he owned Chrome pretty hard, and I'm responsible for Chrome. So I'm property of Pinkie Pie, and some dollar signs have appeared above this guy's head because although it took a while to send to the home team to confirm, he kind of knew it was real, we kind of knew it was real. This is the home team. I've referred to the home team quite a lot. So we're the away team. We have it easy. We just sort of sit behind a booth a bit, chat to some researchers, maybe visit an URL in a browser as the extent of the hard work we have to do, and then go drinking. Whereas the home team have to do the hard work, which is sort of decompose the exploit into the constituent pieces, find someone to fix each piece, get each piece fixed. That's kind of can be hard to do, depending on how tricky the bug is. Find someone to review the fix. If you want to make sure the fix is correct. So who do we have here? Any superstars? I'm not looking too bad considering it's way beyond midnight local time, California. But that's Justin Shu. You may know his name. He's written a fairly well-known book amongst the security community. We have Inferno. And there's our release manager. He's smiling even though he's got a lot of work to do overnight. So this is a picture of a laptop, and this is the laptop that was pwned by the Pinkie Pie exploit. It was taken in low light, so I'm not sure if you can see, but we've written on it, pwned by Pinkie Pie. The Pwnium 2 away team, there were 3 of us, we've all signed it, and we've decided to donate this laptop to the charity auction, which is going on, I think, shortly after this talk ends. So a little piece of history. The laptop's about $600 worth. Maybe us signing it has raised or maybe lowered the value for defacement. We've actually left the effect of the exploit on the laptop, so the exploit to demonstrate that it had, it had control of the machine, dropped a file on the desktop. It's a very clean desktop. It's a fresh Windows 7 install. It has a Chrome logo and a file on the desktop called simply lol. And I don't know if this will increase the value of the laptop or not, but probably the exploit is still in the cache of this laptop. We visited an URL. Browsers cache URLs depending on the caching headers that they get from the site the exploit comes from. So you may be able to get a copy of the exploit in cache. We actually applied the patch to the laptop before handing it over for charity. So you're actually immune against this exploit if you get this laptop. However, the exploit may still be interesting due to reasons we'll go into shortly. So the awesome thing about getting an exploit in yesterday, patching it the same day, is that I can talk about it in moderate detail today. I think that's pretty cool. I love giving out details. So that I can't give out too many details because I've probably given out too many details, actually, but The bug is actually, one of the bugs is in WebKit, and that obviously is used by almost every smartphone on the planet. And patching a phone is a little bit slower than patching a browser, so maybe you can buy the laptop and get a nice one-day exploit. It's called a one-day exploit because it has a limited lifetime because the patch that you can apply is out there, but a lot of devices won't have it yet. So these are the phases that Pinkie Pie went through to get the win. So overall, the route he's gone is he's got code execution inside the sandbox and then find another bug to get out of the sandbox. So phase 1A, you've got to find a bug inside the renderer sandbox so you can get code execution inside the sandbox. It was a bug in SVG, scalable vector graphics. It's a use after free. Browsers are expert at having a lot of use after free in them, so I don't think anyone's surprised there. We actually have had a raft of SVG use after free bugs in the office. So we kind of joke that the SVG spec already specifies a use tag. So just to sort of shortcut exploiters from having to do any hard work, we could just add a free tag to the spec, and then by ordering the free before the use, we can save people a bunch of time. One thing we noted is that, speaking of having a raft of SVGs after free bugs, if you go back a couple of years to September 2010 and look at our release notes on our release notes blog, a couple of releases back to back on our stable channel. I think Chrome 6 was stable at that time in history. Went up to Chrome 22, so we've been busy. But even back in Chrome 6, we were paying out for researchers sending us SVG use after free bugs. So one astute individual who's a bit visionary and put a comment on one of our blog posts. I don't have his name. The handle listed is just NCSPZ. And looking at the trend he saw here, he observed or predicted the SVG module will make Google bankrupt. We're not quite there yet, but we're $60,000 closer, which is the biggest step we've gone closer to bankruptcy of our SVG yet. So we found a bug that's a nice looking use after free in SVG and WebKit. But a bug versus an exploit are very, very different things. And that's reflected in the value we pay for exploits at Pwnium 2, $60,000 versus a good bug in SVG would now probably be $3,000 to $5,000, depending on how nasty it looked. So the big difference there is because turning a bug into an exploit requires a lot of specialized experience. It's quite difficult. It can be time-consuming. I've heard secondhand that total Pinkie Pie spent about a month working on this. I'm sure finding the bug was a small part of that versus weaponizing it. So how do we turn this use after free into code execution? So a bit like this. So there's a lot going on in this diagram, and my laser pointer is working now, so I'll try and see what's going on. So the names of these objects here have been changed to protect the innocent. So what we've got going on here is we've got an object of type SVG widget parent that has a pointer to an SVG widget. And the use after free in the code is such that this SVG widget gets freed, but this guy has errantly kept a pointer to this object that's freed. So if you have a good use after free in the browser, one of the properties it will have is that you, as the attacker, get to run arbitrary JavaScript between the free and the use. And what you can do whilst running that arbitrary JavaScript is you can arrange for an object of your choice to get allocated in the freed slot. So this guy thinks he's pointing to one of these, but actually he's pointing to one of these, which is a totally different type of object that the attacker chooses to suit their needs. And a very good type of object to choose as the attacker is something called an array buffer. It's conceptually like a string, so it's a sequence of bytes where you as the attacker can control those bytes, read and write them. So what he did is he lined up this array pointer and length in the values he controls with values in here. So this guy is reading an array from a pointer controlled by the attacker. And that's pretty serious, but normally that won't defeat ASLR because if you just guess a random address due to ASLR, chances are it may not be mapped, or if it is mapped, it might not be what you think it is. So to defeat ASLR, Pinkie Pie has a little trick that we need to do something about, but there's an issue in Windows 7 where the ASLR implementation puts a particular system object at a particularly consistent location. So that's a known address. You point the pointer to that, and that gives you a primitive where you can start reading what's in that system object, and that system object contains pointers to other things like the heap and eventually where the executable is in memory, and these are the things you need to start a ROP chain, which is the modern way of getting around DEP and ASLR. And the way you start the ROP chain is you also have an overlap here between the freed object and the object we control, which is the virtual pointer. So once you've used this problem here to ascertain the location of all the code in memory, you can set up a vtable pointer that points to a vtable that points to a couple of instructions that will kick off your ROP chain. Just one more thing that's worth noting here. An interesting trick that was used is these activities here we've talked about have been this guy reading content that we've specified. You can also prod a method on this guy via JavaScript that will cause a write into this freed slot, which becomes a write into the object we control, the array buffer. And since it's an array buffer, you can read back that written value. If that was a pointer, that would be another way to defeat ASLR. In this case of this exploit, it wasn't a pointer, it was just a static value, but that static value was used in the exploit to sort of scan through a whole ton of these array buffers to find the exact one that had been allocated on top of this freed slot, and that made the exploit reliable. And I think I've covered all of this. I'm not sure how well known this ASLR bypass is that was used where Windows 7 has a predictable object location at the system level. It's clearly well under Pinkie Pie. This is the second time he's used it, so we're kind of kicking ourselves for not thinking of a way to force Windows to do something a bit different. We looked at it, but it's very difficult. There's a guy smiling because he looked at this. We hear that it's allegedly fixed in Windows 8, so a future Pwnium, if there is one, we'll probably use Windows 8, and we'll see what Pinkie Pie comes up with next. It's worth noting, actually, that Chrome on Windows is currently a 32-bit process. You get much better ASLR on 64-bit to an extent, and on Windows 8, definitely you do. So there'll probably be a 64-bit Windows version of Chrome motivated by good 64-bit ASLR on Windows 8, which is going production soon, of course. So that's phase 1B. So now, after all this, we have code execution inside the Chrome sandbox. So it gives you options. You can attack the kernel, like we discussed earlier, like Nikita Tarakanov was trying. Another thing you can do is you can attack another part of Chrome itself. When you're inside a sandbox, you typically need services provided to you by something with higher privilege. For example, what if a website prompts you to upload a file? Inside the sandbox, or inside Chrome sandbox at least, you certainly can't just read arbitrary files off the disk. So you need to ask, you need to do it correctly and carefully, but you need to ask the privileged end to ask the user to pick a file for upload. Obviously, if the sandboxed code could just say, I want this file, and the privileged end said, here you go, then you don't really have a sandbox. So that's what Pinkie Pie did. He attacked some of these messages that flow between the sandboxed code and called the untrusted side, and the trusted side, which is the side with some privileges that can open files, read files, write files, and provide services. So he went after the semantics, not the syntactics. If you went after the syntactics, that would be sort of bit flipping some fields of the binary protocol between the untrusted and trusted side, but he didn't go after that, probably because that's been fuzzed fairly well. However, the semantics, you've got quite a large number of different messages which you can try and trick, if you like, to doing something that it shouldn't be able to do. So, what fiendish complexity did Pinkie Pie use to bust out of the sandbox? Unfortunately, he found a message where you could just say, hello, trusted end. Here are some bytes. Can you write them to this file, please? And that's not ideal. We're kicking ourselves about that one. We think it's sufficiently bad that it deserves multiple meme gens. So another way of putting it is, you don't always write files based on untrusted IPC messages. But if we do, we're going to trust the file, the path of the file, and the content of the file. Yes, we've removed that message, and an audit was undertaken to make sure, and will continue to be taken in an ongoing manner to make sure that we don't make a mistake like that again. So even when you put as much time and effort as we do in Chrome into security, it's still possible to make mistakes. But that's why we have Pwnium. I think $60,000 is a reasonable price to pay to have that bug gone. And with that, we have about 10 minutes left, according to this thing here. I'd love to answer any questions you have.
So how does writing a file give code execution?
How does what give code execution?
Writing the file.
The question is, how does writing a file give code execution? You can pick, I think it's not just a write, but specifically an overwrite primitive. So so the process doing this write is at the medium integrity level, which is basically unsandboxed. And you can ask it to write to any file. So you could presumably overwrite chrome.exe. I don't see why you shouldn't be able to do that. I mean, if you can write any file at the medium integrity level, it's game over. We didn't even bother to look into it. We just said, win, $60,000, facepalm, Dos Equis guy, all of the meme gens came out. There are quite a few meme gens internal to Google based on this, actually, that I don't think I'm at liberty to share. But it's been dealt with now. Excellent. Any more questions?
No more questions? Then let's give him a big applause. Thank you.